Now the channel is noisy, so it can introduce any number of errors. So which means that any possible 5-bit string can be received here. So that's why we represented this as a 5-bit string. So which means that the set of all possible received bit strings is independent of what you sent here. And in those set of all possible received bit strings, so since there are 5 bits, there are 2 to the 5, 32 possible bit strings. And for some of the bit strings, this check will pass, and some of them it will fail. So I want you to tell me which are the bit strings for which this check will pass. So for that, so I said, this is easy if you just remember that this is a deterministic function. The parity check bit is a deterministic function, and whenever this happens, we declare no error. So which means that I just need to look at bit strings which are of this form. That is b phi cap, I just calculate based on this. And the calculation is b phi cap is 1 if number of ones in b1, b2, b3, b4 is odd and is 0 otherwise. So what I do is, the simplest way is I just list all possible 4-bit strings, and then I'll just calculate the 5th parity check bit such that error won't be declared. So how do you list all possible 4-bit strings? So since as you know, the easiest way is to do this. Maybe I'll do it here. That's 8, right? Same. 1, 2, 3, 4, 5, 6, 7, 8. This is a set of all possible 4-bit strings, and now I just make sure that the parity check bit is that function. Then the error won't be declared. So in this case, the number of ones is 0, which is even, and in this case it is 1, 1. So these are the strings which are declared as error free. So there are some complaints that there are too many possibilities and so on. But if you understand that the principle of how the error detection code works, then you know that it is simple. Because of course it took me a long time to explain this because I went step by step, but you should be able to just run through this in your head very quickly and just do this